Of a square are equal, hence the formula for calculating the area of a square is nothing but side square. This you know very well. And you also studied about the formula to calculate the area of a rectangle. A rectangle will be having its own length and breadth, hence the area formula is length into breadth. Thereafter you studied about finding out the area of a right angled triangle. Right, a right angled triangle is characterized by the peculiarity that one of the angle will be equal to 90 degree, and the formula studied was half into the product of sides forming right angle, right? Then you also studied about how to find out the area of any triangle. That means always it will not be right angled triangle. Suppose a triangle is like this, having different dimension or different size to its sides and different angles. There is no 90 degree angle. That time we developed the formula, or we understood the formula to calculate the area is half into base into height, in which we found that one of the side can be taken as base. The height will be the perpendicular drawn from the opposite side, depending upon which side you are taking as base. This also you studied. Further, you understood in the these things happened when you were in 6th and 7th standard. Further, you studied in the last video especially about how to find out the area of a parallelogram. Parallelogram is a figure having its own peculiarities, where its opposite sides are equal, opposite angles are equal, opposite angles sides are parallel. In the case of a parallelogram, which looks like this, which we studied and made the formula, or could get the formula in the last session. And the parallelogram can be in this format also, it can be in this format also, or any such format. So where in such cases we found that the area can be calculated by the formula area of parallelogram is equal to base into height. Further, you found that there is another figure connected with the parallelogram which is named as rhombus, where all the sides of parallelogram are equal. A rhombus can be like this or it can be like this, but the peculiarity that all its sides will be equal. And the formula to calculate the sides or the area of a rhombus, we found that in the last session itself, as half into product of length of diagonals. What are diagonals? You know very clearly. In this case, the diagonals are this. This is one of the diagonal and this is another diagonal. These are the things you know at present before going ahead with this chapter. The chapter is talking about the area of a trapezium as the next topic. Okay, and area of a trapezium. This is what is a trapezium. What is the difference between this particular figure and the figures which we just saw before? These are parallelogram, these are square, rectangle, triangle, and here we got a new figure in mathematics, what is named as trapezium. The peculiarity of this figure you have studied is that opposite sides or a pair of sides of this trapezium are parallel, only a set. In this case, these are the two opposite parallel sides. That's why I did different diagrams here. It can be in any direction, it can be in any format, but it is a trapezium. If the figure is having a set of opposite sides are parallel. So such a figure is named a trapezium. Now our attempt is to find out the formula, or to create a formula to find out the area of a trapezium. In that case, we will be making use of our previous knowledge, that the knowledge of finding out the area of triangle, especially a right angled triangle and rectangle, in order to solve the, or in order to find out the way to find out the area of a trapezium. So let me name this particular trapezium, which is shown on the screen, as ABCD. It is a quadrilateral, that means having four-sided figure, so we can represent this as trapezium ABCD, and our attempt is to find out its area. Directly we cannot, because this is none of those formula will be directly applicable here, so we should derive a formula. First, what I am going to do is going to draw two perpendiculars within this in order to know the distance between these two parallel sides. For that, I will be drawing a height or a perpendicular over here, another over here, and to identify, I will be naming those perpendicular as the point of contact as P and Q. And you also know that this is 90 degrees, that is why this is perpendicular, and it shows the distance between AB and PQ. I can name it as height also if I consider this as the base of the trapezium. It is up to us whether it is to be named as height or distance, but it can be easily named as height because it is perpendicular distance between these two parallel sides. Another interesting thing, after drawing this particular two heights over here, something comes over here. I just did AP perpendicular to DC, I mean the segment. Okay, also I have done segment BQ, which is this one, perpendicular to again to DC. This is a construction done, and something else happened over here. This particular AB is equal to segment AB by this became equal to segment PQ, and it is also notable that this AP, segment AP, this one which we have named as height, is equal to segment BQ also. These are the things what we observe after making the construction. We could say that this particular AB is equal to PQ, and AP and BQ are the height over here, and DC is constituted by, now DP plus PQ plus QC will constitute DC. With all this knowledge, we are trying to calculate the area of this trapezium, what is named as trapezium ABCD. So let me write area of the trapezium ABCD, which we are going to calculate, can be calculated by calculating the area of this right angled triangle, because it is right angle here. Area of this rectangle, which is ABQP, plus area of this right angle triangle, which is BQC. So let me write it in that format, is equal to the sum of the area of, let me name this triangle as APD, the first triangle, plus the rectangle, area of the rectangle ABQP, then plus the triangle, once again area of triangle BQC. If I add this area of these three figures, I will get the area of a trapezium. In that case, we know the area of a right angle triangle is calculated by the formula half into base, in this case is equal to dP into height, which is already marked as height, plus the area of rectangle is equal to length into breadth. Here the length is AB, breadth is again height, plus the area of the third triangle BQC, where half into QC into height. We can notice that height is common over here, so we can rearrange or rewrite it as H into half dP All these are length of DP, length of AB, you should understand, plus AB plus half QC. Correct? This way the things goes on, where we could make it a little bit short. Again, we can see that half is common here, half is common here, there is no half over here, but we can rewrite it as, I'm writing it over here, we can rewrite it as h into, and I'm taking half also outside, h into half into, instead of half dp I will write dp, plus instead of AB I will write 2AB. 2AB will cancel this 2 and 2 and it will become AB. Then QC. Now something interesting happens here. 2 times AB comes. Why I wrote 2 times AC? Because half into 2 times AB is equal to AB, and I want AB only here. So that will give us an idea. What is the meaning of 2AB? This is AB. 2 times taking that, it is almost like taking AB and PQ. So I'm rewriting it as h into half. This step is this is a real achievement of this. Instead of AB writing 2 times, I'm writing AB plus PQ. Why? Because AB and PQ are equal, plus QC. So when you look at AB plus PQ, AB plus PQ is the opposite sides of this rectangle and they are equal. That's why it is wrote like this. Now when you look at this particular derivation, dp is this one, AB plus PQ means this one plus this one, QC means this one. So if you are thinking about DC as such, DC the base over here, we can say that adding dp plus PQ plus QC will make DC. So I am writing DC. Then what is left is AP. So ultimately what happens here, if I look at this again, it appears as if height into half of DC plus AB. What is DC? One of the parallel side, right? One of the parallel side. And what is the other one? AB, the opposite parallel side. So we can write within, whenever you are calculating this area of a trapezium, it can be half into sum of length of the parallel sides. This is what it is, into height. So this way we derive a formula over here to calculate the area of a trapezium. Nothing but half into sum of length of parallel sides into height. So my dear students, this is what happened when we tried to find out the area of a trapezium with the given knowledge or given information. We could derive a formula. For you, let me write once again the formula for you. The area of a trapezium is calculated by half into sum of length of parallel sides multiplied by h. So this is what is the main aspect of this part of video, where you could learn how to derive the formula to calculate area of a trapezium and what is the formula. Okay, so this is the question can be sometimes straight away, sometimes it will be a little bit tricky. See, here is a question in a trapezium. If the distance between parallel side is given as 6 centimeter, and that means it is already given the h. So I will write h is equal to 6 centimeter, and the length of parallel sides are 7 and 8. So parallel sides length are 7 and 8, means sum of it will be 7 and 8 is given. The sum will be equal to 7 plus 8, and find out the area. So you'll simply substitute 7 plus 8, 15 here, and multiplied by height, which is equal to 6, and the answer will be 45 square centimeter, or it can be centimeter square, can be written like this. So this question is very straightforward and simple. Always it won't be like this, but this is the way by which we solve it. So my dear students, we reach to the understanding of a formula which is very much useful and very frequent in higher classes, and it's a formula of a trapezium, right? And further you have to study about area of a triangle. Area of a triangle, we already know how to find out the area of a right angled triangle, and we also know about the area of any triangle if you know the half into base into height. This base into height will be changing into the product of sides in the case of a right angle. Both are almost same. This formula is clear to you, but always this formula may not be easy to apply. I mean, the information will not be given. Sometimes it so happens that the three sides, the length of three sides of the triangle will be given. Then there is a formula. The formula is named as Heron's formula. So we are having a new formula to find out area of a triangle, provided you are having the length of three sides of a triangle. Suppose that this triangle is ABC and its sides are BC is A and AB is equal to C and AC is equal to B. So we are having ABC as its sides. The formula for calculating the area in such a case where you are not having any idea about the height of the triangle, the formula is root of S into S minus A into S minus B into S minus C. So you will be wondering, ABC are the sides of this triangle. What is S? S is nothing but semi-perimeter. What is perimeter? You know, perimeter is a measure of the boundary or the total length of the sides of the figure. So semi-perimeter is nothing but half of the total of length of these three sides of the triangle. You will get a measure of it and you will substitute that, and you will be solving the problem by the formula root of S minus A into S minus B into S minus C. As there is root and some semi-perimeter calculation, but of course the area can be calculated if a triangle is given like that. For that, I will be giving you an example here from your textbook. The textbook says that if there is a triangle having sides 17 centimeter, 25 centimeter and 26 centimeter, we are asked to find out the area. So as it is three sides are given, we will go for Heron's formula, where you will write A is equal to 17, B is equal to 25, C is equal to 26, and we will calculate S first by A plus B plus C upon 2, where it is 17 plus 25 plus 26 upon 2, which is equal to 68 upon 2, which is equal to 34. We got semi-perimeter. Now we will substitute in the formula area of a triangle, and we write it as S is already available for us, S into S minus A into S minus B into S minus C, and where we will be writing root of 34 into 34 minus 17 into 34 minus 25 into 34 minus 26. Now it became pure arithmetic. We are having 34 all over here, and it will be simply taking it out and will be getting the answer as this is 34. Again 34 into 34 minus 17 is equal to 17 itself, into 34 minus 25 is equal to 9, right, into 34 minus 26 is equal to 8. You will solve this and find out the root of it. Okay, which can be sometime, luckily it will be easy for you, sometime difficult. Here it is 34, 17, 9 and 8. 34 can be written as 17 into 2, and we are having one 17 into 2. 17 into 9 can be written as 3 into 3. So we are having two sets of 17, two sets of 3. Then 8 can be written as 2 into 2 into 2. This way, if you split that, you may find it easy to solve. Very rarely you will get this kind of easy solution for this. So you will ultimately 17, two 17s are there, two set of 2s are there, one set of 3s are there. So you will bring it out in such a way that it is just like root of 17 square into 3 square into 2 square into 2 square, which is equal to 17 into 3 into 2 into 2. Naturally, it is equal to 204 square centimeter. Most important thing is learning this formula, which is new for you. The formula S minus A into S minus B into S minus C, where S is nothing but semi-perimeter. Okay, my dear students. So with this, I conclude this topic, and you will try to answer the questions given in the textbook. Not only try, we'll try and try until you get the answer correctly. Don't go for any help from anywhere. There are more interesting things to tell you, which I'll be doing it in the next video, because always it will not be a straight application of formula studied. There will be some tricky observations, tricky diagrams, tricky units in that which will trouble you. So that will be done in the next video. Thank you.
Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.